Hello, everybody, and welcome to another episode of Hard Truths Podcast. This is your host, Ashton Forbes, and today I have a very special guest, Dr. Yu from NASA. Dr. Yu has a unification theory called Uon Theory, which believes that at the smallest level, everything is a magnetic particle, and that this theory can explain dark energy, dark matter, and all of the fundamental forces. Welcome right now, with me on the show, is Dr. Yu. Thank you, Dr. Yu, for being here. How are you doing today?
Thank you, Ashton, for having me. I'm doing great. I'm so excited to have a conversation with you.
Yeah, so right off the bat, did I get Uon Theory correct? How do you explain Uon Theory to people?
Oh, yeah, it is a unified physical theory. Try to explain all the physical phenomena and the mysteries in physics with one particle, one force, one field, one principle, and also one universe.
Well, let's start right off the bat with light. Now, I've watched some of your previous podcasts, and I loved your explanation of what light is and how we should think about light. So right off the bat, tell me, why is light not a particle? Why is light a wave? Or is light a wave? Is light actually a particle and a wave at the same time?
This is the mystery of the light, because we're accessing two different theories. One said light is a wave, another one says light is a particle. Eventually, when the third one say, hey, light is called a wavicle. It's a wave and a particle. My quick answer is, after I studied this one, my quick answer, light is 100% a wave. It's not a particle. But if you want me to subdivide, to more explain, say light has a light source and light propagation. So if we say light source, we say it is caused by particle, is like draw a pebble in a pond, right? Create a motion. So the light source is a particle. However, once the motion started, the motion propagates is through a medium. So then that becomes a wave phenomena for light propagates.
So
I know you explain to me. Yeah.
Yeah, the example that you gave, I think, in the podcast I was watching, which I really liked, just to visualize, was that you said, if you imagine a light in the middle of a room, and we're all looking at that light, in order for light to be a particle, it would mean that the whole room would have to be completely filled with particles. And that theoretically light could be infinitely small, so it would have to be an infinite number of particles, which wouldn't make sense at all. Is that the strongest evidence, you think, for why light would have to be a wave? And if so, then how do you explain the photoelectric effect and this idea of this packet of photons?
Yeah. The photoelectric effect, the short answer is I do not believe current explanation of photoelectric effect is correct. So I'm going to divide it by two things. Number one, the photoelectric, assuming electricity, photoelectric effect, assuming electricity is a motion of electron. So that's why they say, hey, we come out, and also assumption is light is a pack of wave particle. A pack of particle, right? So now becomes a particle and a particle interaction. So that's the current understanding. But after I studied, I found out, no, it's totally different. The first thing is electricity is not the flow of particles. Whenever we generate, the photoelectric effect is when new light come in, we have electricity come out, right? So we're assuming, based on the conventional theory, we're assuming you create the motion of electron and the electron traveling through the substrate. So that's how create electricity. I found actually electricity does not created by any particle called the translated motion. It's actually a vibration motion. It's a wave propagates. So on the solar panel, let's say on the solar panel, light coming in. All the particles on solar panel subject to light excitation, right? They only create oscillation, or called vibration, oscillation, disturbance in local area. However, the atoms on the surface of the solar panel, they are elastic connected. So that's why you create a medium, vibrating medium propagates outside. So
you're saying
this,
then that the light, which is the photon that's hitting, is this electromagnetic wave, potentially just a magnetic wave that's hitting this
right.
medium of particles that's there, and then that's what's producing what we're seeing in the photoelectric effect as this disturbance in the medium?
Yes. So now you just answered my second question. So we are assuming light is a wave. Means light does not come out a whole things, some impact. It's not like an impact. It is a wave create oscillation of electromagnetic field. When you shine the light, what happens is on the surface of that, you create oscillating magnetic field. And then that's the number one thing. So light is not a particle. We think about this as a wave. Of course, a wave have a wave front. Yeah, right. We have a wave front, wave vibration. And a vibration wave, you have a wave front. Go through it, create oscillation of a magnetic wave. However, what the effect once a magnetic wave goes through this, let's say, solar panel, equivalent to photoelastic material, right? Solar panel. So what happens when you have oscillation electromagnetic wave? You create all the particles on the surface of this material solar panel are magnetic particles. So what happens? It will oscillating with the wave frequency, oscillating with the wave. So that means light wave induce the oscillation of the particle on the surface of a solar panel. And then this oscillation in local area create a wave motion along the surface of that solar panel. So that propagates. So if you
keep going.
Yeah, if you based on this one, you do not say how much pack of energy to knock electron out in order to make them a motion, right? We don't need to knock electron out because electricity does not require translator motion, just oscillating. That's it.
So why? Because then Einstein would say, right, that the size of we can interact by changing, I think, the frequency, right? We change the size of the spoon is the analogy that they use in terms of like how we're interacting. So what would be your explanation there for like that we can change the size of the spoon by changing the frequency? How does that? We're like changing the excitation by doing that, like we're making the excitation more impactful. Or go ahead.
That's where resonance comes in. Okay. You need to hit the resonance frequency, right? You adjust frequency. Not every frequency is a resonant frequency. Only in the resonant frequency, you use the smallest energy can propagate. You like the word resonance, do you?
I love I mean, and I can already tell, like, this is pre-recorded, but I already know the people in the chat are all yelling Tesla, Tesla, Tesla right now and things like that. Because, yes, resonance, I think, is something that I love your opinion on this, but it seems like it's discounted in physics. And yet, like, I use it every day when I turn my radio on, and tune to the right station, and then all of a sudden hear music.
That's a problem with the theoretical physicist. They are starting point. They cannot think without a formula. Somebody gave them a formula in front of them. That's the problem. They cannot, so that's why if you do not have a day work in real job, dealing with true universe, right? How can you truly understand how electricity works? And how light truly works?
Yeah, no, absolutely. And the resonance thing now, it's also making me think of you were debating or talking with Terrence Howard. You had a great discussion with Terrence Howard, and it makes me think of Walter Russell and that periodic table with the resonance on it. Do you think there's some merit to that viewpoint of looking at atoms like in terms of resonance like that? Then, if everything is a wave.
Yeah. Resonance is every structure has its own natural resonance, right? No problem with that one, right? Yeah. And then every multiple of frequency, we call it eigenvalue. We have an eigenvalue. Any multiple integer multiplication of the same value, the fundamental frequency. If you times any integer value, it is still it is still called a natural frequency, but just not a fundamental natural frequency. It's still natural frequency. So that means Terence said, hey, I have this one oscillation at this natural frequency, right? If I doubles it or triples it, right? It is still counted as a same family of eigenvalue family. Give you different vibration mode. Different mode we call the eigenvector, right? It's the same family. So I hope that makes sense to you. So it's not violate anything, but but that's not everything. Yeah.
I think you put it beautifully because I've looked at that periodic table and it makes conceptual sense, like the way you described it, if everything is a wave, but I just don't know enough to look at it to tell, like, okay, is silicon the fourth octave of?
Yeah, he said another octave, another order of the. It's still a natural frequency. It's still a natural frequency. That means that you can still use the same resonance frequency to excite them. Yeah.
Have you ever heard of a coherent matter wave beam? Have you ever heard of that before?
Yes.
And so that would be using that concept, right? Which would be like if you go to the atomic level and say that, okay, rubidium has this certain wavelength.
Sure.
And you can theoretically, like, I think they use these cavities to like vibrate these atoms to the point where they
exciting them
become coherent and become bosons.
Right. Yeah.
Any takes on that? Because that seems like I watched the patent holder talk about it a couple of weeks ago, and he said that it could be 1,000,000 times more powerful than a laser. And I just thought
that's what the principle of a resonance. They do give you theoretically the infinite amplitude. So if he said, hey, millions of times, it's a less than infinite, right? So basically, everything has its natural vibration frequency. How do we know it's a natural vibration frequency? So we basically you just use a hammer to knock it. If this ring keep initially it has some noise, transition period. After a while, it will be oscillating constantly by itself for. That's actually is a natural frequency. So now, if you have excitation, hit exactly the free vibration frequency. That's natural. At that time, what happens? That frequency keep on vibrating, even though you input very, very small. I saw that we have like an army marching over bridge, right? Army marching over bridge. If they march in unison at a certain frequency, it's never about how many people there. It's just if you use the same frequency and right hit the resonance frequency, that's where time is coming in. As time, even though magnitude is very small, but the time is coming in, accumulated energy can increase, it can break that one.
Yeah, that sounds like parametric resonance or parametric oscillations of electrical circuits. Yeah, and that's also, I think, what Salvatore Pais, I've spoken to him, he's a U.S. Navy engineer. He talks about that a lot, about tenderizing, like when he talks about manipulating space-time, he talks about it like that with resonance.
Yes.
And you can use also the analogy of like the opera singer hitting the note for the wine glass to shatter.
Opera singer, the wine glass, right? Yes. If you hit the natural frequency of the glass, and of course you have to last a longer time, right? You cannot just hit the one note, then you jump over, and then you keep at that note. After a few seconds, I say you will see shredded. So that's the power of frequency. Just like you mentioned, someone said, could be 1,000,000 times higher. Theoretically, resonance frequency can go to amplitude, can go to infinity. You know that one, right?
Yeah, keep that in mind because we're going to come back to that. And when we talk about some of the other later topics here, one last topic on light, which is, how do you answer the double-slit experiment? Like, why does the wave function break down? And just to clarify for people out there who don't know, double-slit experiment, we're shooting photons through two slits. We would expect there to be like two slits on the detectors on the backside that matches our two slits. But when we look instead, we get this wave pattern. And so we say, okay, well, how is that possible? Which slit did the photon go through? So we set up a detector. And we just say, okay, we're going to look and see which one it went through. And then when that happens, the wave function goes away, and instead we just get our two slits. This is the number one mystery in all of physics, is that whoever can solve this probably figures out all of physics. So, Dr. Yu, go ahead and solve it for us.
Okay, so you give me the easiest questions about the double slit right now. Okay, so you shooting photons. If you if your audience watched your previous video, it will be know. So my theory about the photon is actually not a pack of a particle. I mean, it's a photon is actually just a wave propagation. So at a different location, you see a pack that's a different particles of the medium particles vibrating at that time. So it's not like a one particle goes through the photon. Okay, so this is the one thing. So when you go through this double slit, if you're shooting one, you know what happens? You're shooting one photons. So we so-called the window. Actually, you just create a one excitation. When you create a one, the photon transmitted or propagated is through the medium. So you see the photon just like somebody swimming over there, right? It's actually the wave motion goes through it. So when the wave reach to the two slit, so basically the shooting photon is equivalent to create oscillation of the wave. So now the wave, that's the medium wave, right? Medium wave goes through the slit. It will not go through a single one. The wave will go through two of the slits simultaneously. So now you have a wave motion in phase, right? In phase, and everything's in tune, in angle, everything. So now you create the double slit. There's a coherent wave.
Yeah. So if everything, so I get the part where the wave part, but I guess I just still don't understand the part where it breaks down and why it breaks down. Like
the
why
breaks down.
Yeah.
The breaks down at when you're shooting electrons. Electrons particles, right? They said, hey, we know electrons particles, right? If this is if theoretical physics get anything right, it has to have some particles, right?
Yeah.
So okay, so electrons particle. They said, if we're shooting electron one at a time, and we observe it one at a time, so go through this one or go that one, we know we can count it, and they find you shooting one at a time, and still find the screen showing the light interference pattern. Okay. That's where I believe people's question come out. So how can you shooting electron, and we know we monitor the electron, go through one slit, or go through the other slit, right? We monitor one at a time and still shoot that one. You know, the key lies in, I know one of your favorite thing is we got the ether back. Is that right? You said the ether. You said
the
got
ether, the ether. Yep.
You know, we know the space. In order for light propagates, we need a carrier. That's a wave. So this wave is made by what? Electromagnetic matters. So that's why electromagnetic wave. So now you think about the electron. What is electron? If you understand I know you understand my explanation. Electron is just little magnetic particles. You think about it, a moving magnetic particles inside a magnetic medium. What happens to the medium? The medium will create a wave. Yeah. So now, when you go through the two slits, your electron goes through it, but the wave, the carrier wave also goes through them. The wave started with what interference pattern, and you know how small electron is, right?
Yeah, it's tiny.
Electron, is element supposed to be element just tiny, so it will carried by the wave. So eventually, and the wave still interferes, right? Just like a light wave. Yeah. So now your electron very small, being carried by that wave. So that's why end up showing the same wave pattern. I don't know if you feel that. Remember one thing is electron is a magnet, which means electron itself carry magnetic field, right? Carry the north-south. So this magnetic field interact with the medium, the electromagnetic medium field. What happens? Vibration, wave.
Yeah, so you're saying that it's actually, I think I get it, is that so the electron is a little, assuming the electron's a particle and it's also a magnet, and
Yes.
we have this medium, there must be some medium, which that's the next topic I want to talk about, then there would be a wave disturbance from the electron moving through the medium. So
Yeah,
you can
from
maybe get,
electrons magnetic field, right?
so then you could have a situation where the electron can create a particle type effect and also one where it can also create
Yes,
a wave
yes.
type effect at the same time.
Yes.
And I have thought, the reason why I like this is I think the answer must be that there is this extra dimension, this extra medium of kind of energy or what have you out there. And physics understands that to be real. So that's why I like that answer. And so then my next question is, well, where is energy coming from? Where is electricity coming from in your view? If you're telling me that we are in this medium of particles of energy all around us and that light is an excitation of
Yes.
that,
Right.
so then wouldn't that mean that the electricity and energy is locally coming from wherever that excitation is occurring? Or go ahead and explain to me what your concept of electricity is.
Oh, I do believe if the energy level are close to because the light is electromagnetic oscillation, right? Wave propagation, and because we have a light transmitted through this medium wave electromagnetic. So if we can see the light, we know the whole medium is in the background is vibrating, is carrying. We do just like a fish. Fish do not see water, right?
Yes.
The water vibrating. However, we do see, we can see fish, but the fish does not see water. This is the same thing. When we see light, just like we saw fish, but we know the fish has to go through the medium, right? So that means the medium is constantly vibrating. The reason is if it can carry light is vibrating. Of course, the medium. So what is it? Those what is a cosmic microwave background, right?
CMB.
Yeah, of course the medium. You have a light, you have a thermonuclear explosions on the stars. These are create huge explosions, huge waves, huge disturbance. Of course, everything's vibrating. You will have energy anywhere you see light.
So where's that energy coming from then? So I mean, you're saying then. So are you talking about 0-point energy? I mean, to me, it sounds like you're saying there's an ether, and this is what Tesla. And
It has to have an ether.
has to
Yes.
be an ether. You think? Oh wow.
Without the ether, you won't be able to see light.
Yeah, because everything requires all waves require a medium, right? I mean, it seems pretty obvious to me. Why do you think physicists have discounted that? I mean, what is the counter argument to that? You're saying space is not empty, really. That's the end of the day. Really what you're saying, right? Space is
probably
really empty.
right. Probably it is the same scientific discussion, and somehow being sidetracked by political issue, maybe social issue or political issue, and somehow certain point of view has to be shut down, silenced, maybe. I don't know, but I noticed a lot of contemporaries, as Albert Einstein's contemporaries. They believe light is a wave. Wave need a medium, and they should have some kind of transmission medium there. And then right now, I try to avoid the word called ether. It has a negative connotation. So I would say, hey, just simple, call black is black. Say it's just a magnetic, just magnetic medium. Light is a magnetic, electromagnetic wave, right? Of course, carried by electromagnetic medium. You may think, you may notice I always struggling with the word electromagnetic or magnet or something, because in my mind, only one type of wave, magnetic wave.
So are you talking about the 0-point energy? Is that what you're referring to?
The 0-point. Can you define 0-point energy to me? I think I know what you mean, but can you explain to audience? So what do you mean?
If I'm in a box here, well, I don't know where the width of this box is, but the screen is this box. If I were to take all of the photons and heat, all of what we would think of as the non-vibrational energy out of this box, then we would say there's no energy left in there. Conventionally, we would say that. But if we were to do stuff like take the Casimir effect in that empty box and we were to put two plates together, we would see them come together. And you would say, how is that possible? You took all the energy out of the box, but we're still seeing plates come together on their own. So there must be some energy there. And,
Yes.
from what you described to me, sounds like to me that's the answer to what you're saying, is that where's that light coming from? Well, it's not coming from the thermal energy. It's not coming from any other energy in this box other than the vibrations, the 0-point energy that's there.
The medium. I believe that's, if that's to say, hey, all the observable particles, everything we can feel, something, take it out. We know the universe, the space is not empty, right? Not a vacuum. It's filled with this electromagnetic medium. And this vibrational medium that's transmitted the light and create the temperature. So you might know, right, that the coldest temperature in based on observation, right, still like a 3 Kelvin or something. Yeah, something around that one. It's never be a 0, right? Yeah.
Yeah. But they, and then the whole idea too is that like they cool down, they create these artificial environments where they cool things, the region down to like absolute 0. And then we also have like superfluidity, like helium-3 will still act like a superfluid. It doesn't freeze. So there must be some energy there, just even using conventional physics to explain that. And then the big argument is, the vacuum catastrophe. So where do you land on the vacuum catastrophe? Do you, what do you think the true energy, the latent energy of the universe is? Do you think it's just what we see with respect to heat? Or do you think it's the answer of when, Feynman and Wheeler took quantum mechanics and they added up all the modes, all that 0 point, and they said, oh, it's 120 orders of magnitude or something like that. I mean, it's like the difference is huge. Like, so who's right?
Like a superposition. I just give you intuitive, simple answer. Say, hey, we know space filled with this called magnetic fluids, right? Okay, so where the energy come from? Because we do have a star, galaxies. You see those bright lights or something. Where they come from? That is from a new thermonuclear explosions. So what that do? They create a huge moving, time-varying magnetic field, right? So even though we cannot see the stuff, we know the stuff is in motion, have energy. That's why we can see light. Right? The light is the vibration through that one. So we know that's the background of the wave is never truly be stationary. Still, because if a light goes through it, the light traveling through all the 3-dimensional space. So it will create oscillations.
Well, so let me ask this, because when you say that and you say, okay, any movement through space is going to be creating these excitations.
Yes.
I start to wonder, shouldn't like free energy be possible? Free energy in the sense that like we have unlimited energy to tap into. Because if what you're saying is true, then stars and the light and the energy coming off stars are just a byproduct of this interaction happening in the medium. And we should be able to recreate that, even produce it at a smaller scale. And I go, well, that seems like that's just unlimited access to energy if we could figure that out. What do you think?
Yes, I think that's true. So basically, once we understand based on the Uon theory, everything's started with fundamental with magnetic particles, magnetic medium, magnetic objects, right? So everything, all the universe built by this single force, magnetic field force, or I think force. So I believe anything natural can happen, we can repeat by human being. Use this fundamental principle, and remember, you said one thing is about use resonant frequency. We do not need a huge energy. We can create almost infinite magnitude. I believe so. That's why I do believe what is called a low energy nuclear reaction or something. And if you're talking about the 0-point energy, it's all about the medium, right? The medium. If you can excite this medium at a certain resonant frequency, which excitation does not require lots of force. You just constantly small excitation, just with a period of time, right? Accumulation of time, it can create a huge energy. That's why I do believe we can create like desktop of a type of a nuclear. I'm not using nuclear fusion. I have a different definition of fusion. So a nuclear reaction device create unlimited.
I was going to ask you this.
Cheap light. You go ahead.
I mean, a star, we're just trying to recreate a star with fusion, and the secret to the star is gravity. You know, it's not temperature, it's gravity is the secret, and then gravity produces the pressure and the temperature. And we've just been discounting gravity this whole time. No wonder we've never figured out fusion for 70 years. And then you come in with Uon Theory, and this was actually on my list of questions to ask you, and I go, if everything's just a magnet, and, you know, I sat and listened to you talk about how, okay, well, it's going to repel because they're both like charges, but if they get too close, it's just a sphere, so it's going to rotate around, and then it's going to connect back together. If you have control over that, over all four forces, the fundamental forces, you can cause fusion to happen at will. And if you can cause fusion to happen at will, that's access to unlimited energy, in my opinion, just from basic chemistry, right? So I thought about that, and I wanted to get your opinion then, because if that's the case, we don't need hot fusion anymore. Like you said, we should be able to produce low energy reactions by manipulating the forces at the atomic level, at the base level. And that kind of scares me, because I think, like, do you think they've already figured this out, or do you think you're the first one?
No. Not only in the United States, I believe even in the rivals to United States, other countries, they still use a false fusion theory, nuclear theory. My major engineer mechanics, right? My advisor is a nuclear engineer professor, and he eventually became the department chair of nuclear and engineering physics department. So I know a lot about nuclear reactions and nuclear engineering theories. I was his RA student, TA and RA, right? So, the reason of all the money we invested, what is it? Every time I heard like $20 billion, $40 billion, probably accumulated over hundreds of billions, at least 200 billions worldwide. They use the best and the brightest physicists to do that, never success, because they misunderstood the fusion. Actually, I just let you know, there are no energy created by combining two things together. That's called fuse them together. That's a wrong concept. So, however, we do measure when I have a nuclear explosion. We do measure okay, we do have a side product. We do have formed helium, right?
Yeah.
So just started with fusion nuclear, hydrogen, something, and eventually forming helium. So we thought, okay, it must be fuse particle together create energy. That's opposite. Let's see if I can explain to you, and if you understand, I want you to explain to your audience.
Okay.
So what happens is, I believe we have no problem with fission. Anything you split two, if you do energy calculation, you double, you increase energy. Mm-hmm. So means whenever you split one object to smaller objects, use same force pushing them, you increase the energy. So the fusion, when you bind them increase, that's not. Whenever you bind two things and let them both moving together, you're slower. Okay. You're moving slower, so that means that your energy reduce. So then, where comes the helium? The helium forms, right? I believe the fuse is called a nuclear hydrogen bomb or fusion bomb or something. Nuclear fusion is split atom to a smaller. Your nuclear bomb, you just split a nuclear, split molecules, into little atoms or something. Yeah. But if you say fusion, you split the atoms to the subatomic smaller. What is the subatomic particles? Based on yours, they're all magnetic particles, just smaller parts, magnetic particles. When you split them, you always increase the energy. So what I believe, so-called atomic bomb versus a hydrogen bomb, the difference is you split at a deeper level, 1 order magnitude deeper, make particles sleep bigger. However, what happens when you split a subatomic particle? All the particle becomes charged, right? However, once they're cooling down, you know what happens? The charged particle are magnetic particle.
Come back.
When it's high energy, they flying everywhere. When cooling down, they start to
Recombine.
connect together. That's form of helium. So helium is a side product after deeper level of fission reaction.
That's really interesting in the context of like Stanley Meyer and his water-powered car.
Yes.
Where he was arguing that he found a way to, at low energy levels, cause hydrogen and oxygen to come apart. And then he basically just moved it to a new area, and then
Yes.
like a normal area, and then they would come back together just naturally.
Come back together, and they also form, I believe they form helium, neutral helium particles.
Yeah, and they saw transmutation as well.
Yes, and they've been crushed, right? They've been trashed the entire. I thought, actually, you know what kind of force make them neutral? Use electricity. You know, electricity is what is oscillating vibration, equivalent to excitation force. If you have electricity hit the resonance frequency of whatever you are testing, right? You know, eventually gonna break atoms apart. I believe that's the right way to go. I want to finish my thoughts about why the big money use high temperature could not create a fusion energy. You know what happens to charged particle? So let's assuming they already high enough energy to make it all become charged particle. The only thing they can fuse together is when you're cooling down. Okay? Now the charged particle they slow down, so they no longer hit each other, bumping back and forth. They started connection, right? That one. But the current theory say you have a huge temperature to fuse them together. You know what happens? They never fuse them together because high energy make them keep constantly moving. You never see you do not see helium come out. What happens? They increase the temperature another order of magnitude, and that problem comes. Your container cannot hold that temperature, right? You have to you create the plasma, keep them away from a wall. This has become a new technology now. How you keep the heat, right, away from the wall, container wall. That's totally. They could come up with different, material, new materials, right? Hold the hydrogen, but it's not going to make a huge fusion work.
Man, I think we should go into a consulting business. Maybe we can help solve some of these fusion companies because like I had the same exact thought, and it's just a logical thought. It's like, okay, you're increasing the temperature and you're making the molecules bounce around faster.
Bouncing around, hitting back and forth.
How is that going to solve anything? That's just
how can you fuse them together, right?
Just random chance. We're just going to hope that they randomly hit each other in all of the space. It's like, as opposed to using a magnetic approach, which is like we're just going to force their paths to come together. Like that just seems so much more obvious to me. So I don't want to get too much into the conspiratorial aspect of it, but I am very skeptical that why haven't other people figured this kind of out already? In my personal opinion is they probably have, and then it makes me question like, okay, well, are we being kind of like, for example, what I will say is that when you speak to energy amplification through vibrational amplification, that's dangerous. Energy amplification in general is dangerous, and it wouldn't surprise me to find out.
You have to control it, right?
Exactly. And so it surprised me to find out that yes, we could do fusion very efficiently using these concepts, but that it's also very dangerous, and that we also don't want to just give that to everybody out on the planet. Would you agree with that? Like, where do you stand on the dangers of some of this science?
I believe if you use not high energy, high temperature, use electromagnetic induced vibration, to try to create resonance to a material, you can split them off. When you split them, you know what happens, right? That's where people ask, where the nuclear energy come from? Two connected particles, magnetic connector. When you split, you know what happens? When the split and the bouncing back and forth, when the bouncing back and forth, you have a attraction and initiate a repulsion now. Attraction, repulsion, so the back and forth energy start to increase. Not just the regular called impact. Wow. If you have a like charge particle impact, the higher you impact, the bigger the repulsion force, right? So that back and forth. So now you see, everything's started, energy increase, heat, and so energy increase. That's called the magnetic repulsion. I believe that's where it play a huge part of the nuclear energy.
Well, if any spooks are watching, I just want everyone to know that Dr. Yu from NASA just taught me how to make a fusion bomb. So you know what? It's not on me. You can blame NASA. They're the ones who taught me how to do it. I'm just kidding. But no, that's good. I appreciate that conversation. But let's move just a little bit away from the possibly end of the world, creating destruction bombs. And I want to ask more questions on Uon theory in terms of how it can explain stuff in cosmology. So I think I understand your explanation of dark matter. That one I think is the easiest to explain with Uon theory, because I've already been thinking for like 15 years that like can't magnetism just explain this idea that galaxies, the stars in our galaxies are rotating faster than we would expect if we just had like a pinwheel. So
Only,
they say, oh, go ahead, jump in.
you said faster than we expected, only when we use Newtonian concept.
Yeah. But if we use electromagnetic concept or magnetic concept, then the speeds are actually match what we would expect. Is that, you know, we've got this, if you just use like the right hand rule in electrical engineering and you just look at the rotation of the galaxies, then it all makes sense. That part, no problem with. The part I think I need a little bit more explanation on, maybe not, is the dark energy side of it. So dark energy, the way I look at it is like if I had some paint and a canvas or this table, and I pour the paint on the table, it's going to spread out kind of all over the table evenly. That's kind of how I imagine like space-time spreading, or like the energy spreading out throughout space-time to create, you know, our reality. So when you explained it, I think you did. I love your plasma globe, by the way. I got to get one of those for my back.
All kinds of okay. Good.
When you put your hand on it, I like the idea that you're like, oh, why do the tendrils, why do they all spread out? Like, why aren't the tendrils like coming together? They almost look evenly spread out. So I guess what you're saying there is that there's attractive and repulsive forces that happen on these large scales that would cause then like the kind of paint to spread out over the canvas, or what is your analysis of how dark energy is solved?
I believe it could be you spill the paint, right? Mm-hmm. Spread it over, and of course it follows the least resistance path, right? Yeah, mm-hmm. When you spread. But you know, for the plasma ball, because you know at the center of that's Tesla coil on one side of a Tesla coil. You know, Tesla coil is highly electromagnetic, generate electromagnetic field. So when we use one tip ball on the top, right? So that means it's all the same. The like pole is all started with the same like pole. So that's why you're shooting those called the filament. The filament is all started with a like pole. So that's why repulsion. And since everywhere repulsion, so that's why you would see each pushing together eventually almost uniformly in all the directions. Does that make sense to you?
Yeah,
you explain to you.
Yeah, you just reminded me of a different thing that you showed where you had like a magnet, right? And you put like 3 poles in it, and they spread out from one another. Oh, you have it? Yeah. That was actually the best visual now, because now that made me think of it.
Oh, you think this visual better than shooting that one? Yes. Yeah. You know, I have a strong neodymium magnets inside.
Yep.
And I put this one inside. I like collect all the physical souvenirs. But my son told me, you should not use this one as an example. He said people would be definitely distracted by the leaning tower. Yeah. I just use it as a holder of a magnet. Okay, so now I have 3. You know, this is just a stainless steel, you know.
Yep.
It's some kind of steel. It's itself not a magnet. But I try to say how to demonstrate the like pole repel. I said, hey, since I have magnets all on the bottom side is one side magnets. I hope you can see it, right?
Yep.
And then put another one.
Yeah, and they repel. So,
oh, you like this one better than
that makes a lot of sense to me, because then I look at that as like the universe is like, oh, no wonder they repel, because you can see they repel more and more and more as they get further, like as it kind of expands out.
Oh, yeah. Okay, so I may use this one more. Sometimes I use plasma. I thought, hey, that represents the universe. How universe works. Yeah, so basically people can understand. So the so-called dark energy, or we call it dark force, just pushing something away from each other. Just magnetic repulsion, right? You have to, yeah.
No, that's good. I like that. Let me ask though. Then, how do you explain? These are two questions I don't think I've seen you explain. Maybe you have. How do you explain mass and inertia? And there's an equivalence principle between the two as well. So how does magnetism alone explain why there's mass at all?
You ask a great question. Actually, that's a one mystery about the mass, right? I do. If you think about the origin of mass right now, under quantum mechanics frame, we solved was 2012. By Higgs, right? Higgs boson, right?
Yep.
So that's try to solving where the mass come from based on the quantum mechanics, or everything's a single a point particle. So how could a point particle generate the mass, right? So they use called interact. Use this a point particle interact with a field that they call the Higgs field. Now my question is, does a Higgs field, how does a Higgs field can interact with a point particle? How could they interact? Use what interact? Because a Higgs field, I believe, if my understanding is correct, it's a neutral field. It's not a magnetic field. Is that right?
Yeah. I think that, yeah, generally I haven't heard enough explanation of how the Higgs field, my understanding is the Higgs field does not adequately explain where all the mass can come from.
No.
And
So
now here's
now-
where I would push back on you, or push back on that and ask you, is that I would say, why doesn't the 0-point energy just explain it? So, you get rid of the Higgs field. And you say, okay, instead of that thermal energy that we've got out there, let's take that 0-point energy, that vibrational energy that you talked about that can amplify to
That's
infinity.
where the medium, I'm called the medium. The medium could be at a 0 point, right? Or at any point. Yes.
The
That's
medium's what's giving you mass.
That's where
the secret,
the medium
right?
interact. The medium interact. The medium electron is a magnetic medium, okay? Interact with particle. What particle is? All particle made by magnetic particle. So that's why they interact. You have resistance. I hope I solving the mystery of mass, right? That's what is called the mass is a resistance of motion, right? That means it's a force, can changing motion.
Bingo. And that's why there's an equivalence principle between inertia and mass. Because when you move around, you're just moving through the resistance of the magnetic moment, if you want to consider that. Like, the same reason why I can't move my hand through this. Like, there's repulsion that's occurring there. And that happens even on the small scales, even if I was in outer space. Because even in outer space, there still is that 0-point energy. Even if you remove all the energy from a space region, you're still going to have that inertia. You're still going to have that mass. And this is why I love your theory. Because you can literally just set the idea of 0-point energy right on top of your theory. And it makes perfect sense.
That's the medium. You cannot, if you place without the medium, you won't see light. You won't see anything, right?
And if one more thought is that if anybody were to say, oh, they want to challenge it, which I love for people to challenge, is that even Leonard Susskind was asked about, if we remove all this energy, how can there be something there still? Well, how can there be something there? And he goes, yes, there's something there, and it's electromagnetic. He says it has charge. And they go, how can it have charge if there's no mass, if there's nothing actually, if there's no energy or mass there? And that he says, I don't know where it can come from. Well, you just said it. There must be a medium, and that medium's electromagnetic. And it's
interact with moving particles are magnetic too, right? They are interact.
Everything's magnetic. So isn't it just a beautiful kind of way to piece everything together? And I love also, too, that you can now explain from your magnetic Uon theory all the fundamental forces. And we don't need any of them. And the thing that's beautiful about physics is the simplest answers are usually the best, right?
I want your audience to understand how it unified, let's say, a strong force. Do we need a strong force? I want you to explain it because your audience will understand that.
Yeah, so like the strong nuclear force. Why, if I take two positively charged or two negatively charged things, if I bring them together, they should repel.
Right.
But if they get too close,
if
they come together, right? So the reason why that is, if you imagine they're balls, if you imagine it's a ball of charge, a sphere of charge, then yes, they will repel at first. But if they get too close, the sphere is going to rotate, and then then they'll attract together. Boom! Now you have the strong nuclear force. And then when you describe the weak force, this was the one that I had the hardest time to understand, but when you showed the image, it made so much sense. is that we see this beta decay. We'll see this spontaneous decay where we see electrons get shot out from our nucleus. How can that be possible? Well, it turns out if we slam something in to our atom, our nucleus, then we'll see stuff get shot out the other side. So
conservation of energy, right?
Yeah, it's just conservation of energy, and we're in this medium all the time. So of course things are interacting all the time. Things are getting hit all the time. So that would explain the weak force as well. And then gravity, I think that your view of gravity works perfectly well with 0-point energy, because the 0-point energy is also electromagnetic, and what we're basically just saying is gravity is an electromagnetic force. Your explanation of taking the magnet, let me see if I can use like my phone, right? Or actually you have the magnets, right? If you could do that explanation, that'd be great. Yes, please. This is the one that I loved. Oh, you know, even when you showed this the first time, I didn't even know what was going to happen, which just goes to show that even somebody who's been studying physics, you don't know, like, that's a very powerful magnet right now.
Yes.
And it can pick up something very, very heavy, right? Look at that. But then all you do is fold it in half, right? Yeah, there you go. Perfect. So even that tiny ball, yep.
Yeah, I believe I can pick 2 balls together.
Oh, wow. Yeah.
I cannot pick 3, okay? So then my question is, what if I fold this one? I'm so happy when I watch you. I know you even stop your video, ask people questions, right? So I said, hey, so these are just regular magnetic interaction, right? Nothing serious. What if I fold this one, make center of gravity lower, and let's fold again? Yep. I believe Patrick Bet David for my trap this one,
yeah.
And so does Terrence, right? Terrence Howard. I said, hey, if I make center of gravity lower, I will try to mislead them, and then, so yeah,
it's so counterintuitive though, because most people look at that and they think it's still going to pick the stuff up.
Basically we have a stronger magnet closer to that one, right?
Yeah, it should be stronger, right? But logically you would think it was, but go ahead and do it.
Almost 99% of people say that one. If occasionally somebody say that, I may not even believe he know what his understand. So if I do this one, everybody think about it. Now you should pick up all 3 balls.
Can't even pick up any of them. Yeah. Can you even pick up the small one? No, right?
I hope you can see my small ball. Can you see small ball?
Yeah, can't even pick that up. Wow. Incredible. So
what happens if I fold even more?
Yeah, it's going to get even weaker, right? Or no, because it can get stronger again after it starts to become long again, though, right? Or,
you mean if I unfold your long, then it's stronger. But if if I fold, make it even compact.
Weaker and weaker. So I have 2 questions on this. So my first one, I guess, is what is superconductivity? How do you explain superconductivity? Because it repels all magnetic fields, right? So how does that work in the context of this theory? And then I also just want to say I love that, because what you explain there, and all the physicists come to me when I say that electricity unifies general relativity and quantum mechanics, and they say, oh no, gravity is too weak. And even though you look at the terms, the actual equations, and you realize that electric force and gravity have like the same formations in terms of the equations, it's just the constant that's different. Okay. And so people say, oh, why is it weaker? Well, you just explained it, because you just fold it in half. Now you've got the same amount of mass, but your force just became much, much weaker. So thank you for that explanation. But so explain to me superconductivity and how that all fits in the role of this.
I have an experiment to demonstrate superconductivity is actually just a magnetic phenomenon.
Nice.
So right now everybody try to strive for called room temperature conductivity, right? Yeah. Super does not means good. Super means you have to be a super cold temperature, right? Yeah. Room temperature conductivity, that's what we really want to apply. So if you allow me, I'm gonna just set up if it take too long, you can cut a part off. I'm gonna show you. I'm glad.
Take a minute.
So,
We'll have them edit it. It's no rush.
no problem, right?
Yep.
So then I'm gonna show you what I have here. We have a room superconductivity too. You know, yeah. So that's what I try to say. So I have a. Oh my goodness, you know. Okay, good. Whenever you're dealing with the magnet, you know, you said it very well. Everything boiled down to magnetism, right? So that's why. So right now, let me see how can I demonstrate this one to you. I have 6 magnets. Can you see that one?
Yep.
Yeah, you can see the magnet. So I'm gonna just keep it in here. You can see that, right? Okay. Yep. So now, what happens? Oh, what happens is here. I have this called a graphite. You know, just type of a graphite, different shapes. Let me see if that can make any sense to you, okay? And that's demonstrate what is the room temperature superconductivity is, okay? I'm not sure if the okay. Let's use this one. Oh, I have to take it out. Otherwise, I cannot say, hey. Did you see this thing's floating?
Yeah, okay.
Actually, can you see it's floating?
Yeah, I can see it. Wow.
You can see that, right? Yeah. And I can, if I have a piece of paper.
Oh, yeah, so it's definitely hovering above the top. So why, though? Is it because of the configuration of the magnets that you put it? Is that what you're saying?
So you do see it's hovering there, right?
Oh, yeah. Oh yeah, I mean
okay.
The paper makes it pretty
obvious.
Yes,
as long as you can see it, so you know it's hovering. So this is exactly what called a room temperature, conductance. Yeah. You know, so basically the so-called resist. Remember, electricity. The reason with that we said, hey, if we can reduce electrical resistance. So we can have a constant energy, never. So that's why we have unlimited energy because it's never consuming. Yeah. That's a wrong concept. You know, if you think about it, the so-called electricity is oscillation, right?
Yeah.
The oscillation. So where comes the resistance? You know, the particle oscillation. Where comes the? You know, when the oscillation, you create a rotational. Acceleration, right? Angular acceleration. Mm-hmm. So resistance is created, so the accelerated this angular momentum. You know, right? Mm-hmm. So that's where part of the resistance come from. Another part, you know, probably for friction over heat. So the particles random bumping each other, right? So when they're oscillating, they could be a little bit bouncing each other and reduce some energy. So that's why it never. There's nothing called a resistance of electron motion. That's what the current definitions. We said that electron move on the super disk. So that's why if you can reduce the resistance, it can keep on motion. No, that's not where the resistance come from. You know, it's also oscillation.
Because you know we've seen stuff like. Crap, I'm trying to think of good examples. But so like Cooper pairs then. So like, well, what is a Cooper pair then? If you're saying that it's, you know, a local excitation, therefore nothing's actually moving, but we've measured superconductivity and we're seeing these effects. So what actually is it then?
Oh, that's where you come after to magnetism. You remember what they do is they put a cold temperature. You know what a cold temperature can do to water? Make water to ice, right? Yeah. Mm-hmm. What the difference between water and ice? They crystallize them. Basically, you align the negative, positive grow the crystals, is negative, positive, you align them. So what happens? You form a magnet. So now magnetic force, you form a magnetic force. The same thing happens to called the superconductor material. The particles and the super cold, what happens? Super cold basically create a condition, just create a condition less friction. So that kind of free rotation now. Free rotation, so basically all the particles started lying as a magnet in every layers. They all becomes a magnetic particle. So that's why this graphite. The graphite have a one layer, layered different layup, and on bottom is a one magnet pole on top. At the different layers, different magnet pole. So that's why you would see suddenly suspended. Oh my goodness! I have another evidence to show. I'm not sure if it's.
It sounds a lot like magnet inversion. Is that what you're getting at?
Yes, exactly. Magnet inversion. That's called diamagnetism, right? You somehow make it also becomes diamagnetic. So that's what cold temperature do. So do not believe cold temperature truly can make a resistance to zero. The most of the resistance, when you make a particle oscillation, you're consuming accelerating force, consuming to accelerated particles, right?
Yeah,
that's part of resistance. Of course, other part is due to heat or something, reduce the motion.
This makes a lot of sense. Remember LK99 with that room temperature superconductor? They did experiments, and the big pushback was that it never got to absolute zero resistance. Like it was really, 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 really low, but not actually zero.
And still have a similar resistance, basically. Yes, I remember.
Even though we're looking at it levitating, like we're literally
right. It's levitating, just like a superconductivity. Just like a magnet is floating, right? Yeah.
And that would imply that it's something fundamentally they've misunderstood about the concept in general, and that's what you're saying here is that. As you cool it down, the lattice structure of the magnet forms in case of water
form a magnetic structure. Yes,
freezes
that's
in
right.
place. Yeah. And so you could see that same thing happening when you do that to any material. And so that's why you might see that. And then you could theoretically, create that same effect at a higher temperature. And this actually makes me think of another question I wanted to lead into, which is, do you think we can make like coherent balls of plasma under this theory? So if you're saying everything's magnetism and we can control all the forces, and we've been talking about fusion, why can't I just make a ball of plasma that can float around freely? Because theoretically I can control all the forces at the fundamental level.
Oh, sure. This is very similar to anti-gravity force, right? If you can control,
go ahead.
Gravity. Okay. So, I just say I give you my results from Uon Theory. Say gravity is just like a magnetic attraction, just magnetism. It's part of attraction, part of magnetism. If you're watching the PBD, that podcast, I use a different language. I say, gravity is a manifestation of magnetism, or is a summation. Remember, summation of electromagnetic body. Summation of a mass system. When you have a lot of mass together, actually you reduce the force, right? It's not like you increase mass. So I use called a summation, or called a residual force of this magnetic body. You mean it? So basically, so the gravity is a magnetism. Part of magnetism. So
just to cancel out, any anti-gravity would just be a reverse charge or a reverse force going the other direction, then, right?
Since gravity, we saw the attraction only force is is part of magnetism. But however, magnetism has both attraction and repulsion, right? So we do able to use, you said, a manipulated plasma ball, counter gravity, counter Earth's magnetic field. If you just kind of control the magnetic field of the plasma ball, counter Earth's attraction magnetic field, you are not just floating. You could have been repelled at the accelerated velocity.
You can go in any direction then, right? Like pretty simply.
I hope this justify the UFO phenomenon, right? UAP phenomenon.
I think people that don't see the connection between the UFO stuff and magnetism, like I just don't know how to help them because like I can look at the superconductivity, I can just look at like magnetic levitation in general, and it looks just like all these UFO videos flying around.
Exactly, same.
They got to be using magnetism, right? It just seems straightforward.
I believe if they are more advanced than us, or somebody asked me in the past, could be in the past human race could be mastered this kind of technology, right? You just need to reverse the magnetic field, so then it can build itself, like what is the pyramid or some coral? What is that in the Florida?
Coral Castle.
Coral
Guy,
Cat
right?
or something.
Yeah.
I highly suspect it might be not that complicated.
A couple more physics questions for you. So, do you think that the universe is scale invariant? Do you think that we can make an atom at the size of a human, like scale it up that way then? Because if you're saying that everything's just magnets, like the way you've described everything to me today, I see no reason why you couldn't just make something bigger at the same, scale invariant. Everything's just tiny little magnets, and then you just add them together to make bigger magnets.
That's what we see in the sun or in some of the giant giant objects. We talking about the black hole. What is 6 billion times the mass of the sun, right? We just consider is what happens with you have a launching magnets together. You have a limit. You launch them, they started force reduce, right? The field reduce become the neutral. When you too much, what happens is unstable now. Unstable very easily to create what is ejection. Suddenly the force is so weak, right? Suddenly local is instead of attraction they rotate and then becomes ejection. So that's why that's called radioactivity. So that's where all the radioactive material has an atomic number is greater than 86 or 84. If you count it. Everything heavier than that one, so it becomes radioactive. It becomes unstable. So that's I try to answer you. Do we have a limit? I believe once you lump together enough, probably the very easily to create what is called supernova or something. Exploded or something, right?
So
does that make sense to you?
Oh yeah. You're saying the big energetic events, like as we just keep stacking things
Stacking
together.
Together. It's not like you can infinite one. There's a balance point, right?
And even in a black hole, they say, so even if we were to say, okay, we get to this point where it gets so large that we have such a gravitational force that light can't escape, there's these huge like ejections that are like on the perpendicular axis of the black holes, right?
Yeah, Hawking radiation. Just talking about you still have to anticipate. I do not believe we need a black hole, right?
Yeah. I know. I was going to ask you. That's why. And so it sounds like you kind of playing. I was going to ask. You're playing both sides here, where you're saying, okay, well, I guess I think your argument's going to be that it gets so big where it's unstable. Therefore, a black hole couldn't really become stable, and therefore they shouldn't exist. Is that what you're getting at?
Oh, not exact. That part, we know every galaxy or every super giant object, they have a certain limit. Beyond that limit, they create a thermonuclear reaction. There were some dynamic balance, right? Throughout something coming back and throughout something keep repeating this pattern. I try to say black hole is not about we missing matter. Yes, it's not about we missing force. We still have the same force. Just instead of a gravitational force, we use a magnetic force. Does that make sense to you? So we
don't need the. Go ahead, keep on.
Yeah. So if you travel near center of the galaxy, without a black hole, you still probably will be burned. Burned by the objects nearby there. Yeah.
Yeah, the center of the universe, even without a black hole, is going to be, or center of the galaxy is going to be a very tumultuous place filled with high energy reactions, right?
Yes.
So you think that? So you don't think that I guess you're saying that you don't think we need black holes, but they still could be possible. Is that what your kind of official statement is? Okay.
Yes. Oh, I want to emphasize one thing about the black hole. Are you living in Florida or in somewhere else? Where do you live?
I live in Minnesota. Yeah.
Oh, you're in Minnesota. Oh, no wonder you use Central Time. Have you studied in Florida or have you lived in Florida before?
I've been there before. Yeah.
Okay. So my analogy is to black hole is, if you live in Florida, you go through hurricane season. Have you?
Yeah.
Okay. That's where I learned something counterintuitive. I'm living at Mary Island. It's the island, so the barrier island. Every time hurricane, they force you to, to move somewhere else, right? At 1 year, we have a neighbor from Miami. They said, "Oh, we are not moving." They came from Miami. It's more than the central Orlando area, right? They said, "Oh, we've been through this one. Doesn't matter." Okay, so I said, "Okay, I will follow you." So I did not moving. What happens? Hurricane comes. Before hurricane comes, everything's shaking. After the center of eye reach them, everything's suddenly totally quiet. Have you been through that?
Oh yeah, that happens in Minnesota too with the tornadoes. You get to the eye of the tornado and it's just calm.
Oh, eye of a tornado, similar phenomenon. So I said, why is not when it's quiet? Because all the heavy particles, the moistures in the air, completely just like spilled out, just like what a washing machine. All the water is spilled out, right? All the clothes on the wall in the center is completely empty. That's what I found. Oh my goodness, the center. I feel like when is have no wind, no sound, and no wind. I said, where did the wind go? All the particles, the wind particles, is on the wall or on the hurricane wall outside of the eye, and also there is no clouds.
Yeah.
When you look through the eye, no clouds. I feel like it's a complete feels peace.
Yeah.
That's what I believe. That's what happens to black hole. So we call the so-called black hole. It's not because it's black. It's not because the gravity is so strong. No light particle. I believe that's absent of matter. Or called, my son gave him name is called it's called a void black hole. Black hole. He called a black void.
It's an actual nothingness, right? It's like there's actually just nothing there. That's why we see it as a black void, because the forces, everything's pulling around it, just like the eye of the storm, right? You see the eye of the storm.
Everything's spinning out.
If you were in it, you would see nothing. And actually, I love that theory perfectly, honestly. And I wouldn't be surprised to find out that it's real at the end of the day. This makes me think about wormholes as well.
Okay.
Because this is this idea of an Einstein-Rosen bridge, which would say if we make that black hole, that space, what's really happening is you are creating a bridge between some point there and some other point anywhere else in the universe. And that if you were actually somehow to be able to go into that, really you're just going through a bridge, and that's a shortcut between space and time. Do you think that's possible, given your understanding of black holes and what have you? What are your thoughts on Einstein-Rosen bridges?
I doubt that one true, but I'm thinking about how about a black void could have that effect.
Yeah. And
Could they? I have not thought about through this. You may not. The so-called black hole is still object in the center, right? Just point of our particle. So you're still flying there, right? If a black void, you still have an empty space there, right? And you still have a force drag them. So I'm not exclude that possibility. Okay.
I guess the way I would look at it is if the universe is like, I guess hard to explain. Maybe you know the word for this, but like if I go in one direction in the universe and I just keep going in one direction and I end up back where I was, like if I just after a while. If you look at it like that, then I would say this point black hole cannot exist. Like there cannot be a singularity that goes to nothing. That must go and open up to something else somewhere else. So like I would argue that every black hole, if one does exist, must have a white hole somewhere else, either in our reality or another.
You go through the wormhole, right? First the black hole drag you in, right? To the other side, they call the white hole, right?
Come out.
to suck it out.
Let me push your
one
theories
is
even
suck
further
in,
here.
and another one is pushing. So yeah.
So based on what you said here, I see no reason why negative energy couldn't exist. Because you're saying that magnetism interacting with the medium is like churning up the ether. It's pulling energy out of the ether, and then you can polarize it positively, or you can polarize your interaction positively or minus, And I would say, okay, if that's the case, then now negative energy would just be depending on how you polarize it.
If
And
you
so, go
consider
ahead.
positive charge and negative charge polarized a different way, I don't know how the negative energy defined, right?
Hmm.
Conventionally defined energy like as a positive number, right? However, if you relatively, if you define the different way, say relatively absolute 0 degree, right? If you define that one, we could define some energy, right? Below, so we so-called absolute zero could be not that case. So then you could have a different definition. I'm not exclude or not confirm, but I just have a thought.
So,
Depends on how you define things. Yeah.
so then is Miguel Alcubierre's warp drive metric consistent with your understanding? I mean, if what you're saying is true and we can manipulate magnetic forces like this, I don't see a reason why we couldn't have infinite acceleration to a point where we would see relativistic faster than light travel. What do you think?
I believe there is no speed limit at the speed of light. Actually, speed of light in the cosmic scale is a very limited finite number. Yeah.
Would you say then that?
We should.
Okay.
The reason is um, I believe Albert Einstein posed this called the speed of universe, right? Based on the light. In his conceptual, light is a capsule, is a particle concept. If a particle concept in particle traveling, the fastest way is absent of any resistance. So then assuming vacuum is completely absent of any medium, anything, right? So then you could say, hey, if completely vacuum without any resistance materials in it, we should have a maximum velocity. So that's that attraction to make believe there's a limit, a speed limit of universe. But in Yuon case, we believe that the speed of light is just called a characteristic velocity of the medium, right?
Refractive index.
Yes,
So do you
yes,
think you
yes,
can
the
modify?
refraction.
Do you
Yes,
think you can
yeah.
modify the refractive index then of
Right.
space-time?
If you can change it, you can change the density, you can change the strength. So that's why light, speed of light different even in air, different than in water, in vacuum or in diamond, in glass, right?
Exactly. So you do believe then that speed of light is variable, and you
I
think
do
we can
not
modify
believe
it?
it. I do believe speed of the light is not the ultimate speed of universe. No, we definitely can faster than speed of light.
Have you ever heard of this term dynamic nuclear orientation? Have you heard of that before?
If you can define them, I'm not
It
that familiar.
basically has to do with manipulating the spin and orbit, the spin of electrons, so to line them up. So, like, imagine that a permanent magnet's just a bunch of electrons that are perfectly lined up, kind of like we were talking about before. And that if you can manipulate each spin of each electron, like at the atomic level, if you could do that, the idea is that you could create a repulsive gravity. Like that just by changing those around, you could cause your thing to just lift off or move around in any direction. And to me, the reason why I bring it up is it sounds like your theory. It's like, okay, well, if
Yeah,
everything's just a dipole magnet, then
right.
you're just
You
moving it
just
around, right?
you turn turn
Yeah.
turn turn off turn like pole together. You can repel, right? Yeah.
And then you would use magnetism for that. So that theory, that sounds like it could make sense to you. I mean, it sounds like you have.
Yeah, that does not violate anything. I want to make sure before, and I want to emphasize one thing about the connection with electron. We talking about electron monocharged particle does not exist, right? I would replace that term called the Uon. Uon means universal fundamental particle, means business magnetic particle, right? Yeah,
Oh,
and
okay.
then
Yeah, go ahead.
sometimes my partner, that's David Grosky, he said, sometimes I said, hey, electron does not exist. He said, why in the later on you talking about using electron term? I said, I changed the definition. I said, initially I said electron does not exist. So based on the quantum theory, negative charge particle. I said, later on I use electron means, oh, just a magnet.
Yeah.
He think I'm confusing, so I want to make sure I'm gonna instead of say electron, I'm gonna just Yuon. Yuon means magnet. And another thing I want to emphasize is significance if the electron does not exist, a proton does not, only Yuon magnets. What does that mean? That means current atomic model. That's called a propulsion motion model would not be true. What that means? That means entire quantum mechanics built on top of this nucleus with electron clouds or electron orbitals should not be true, should not be there. There's no free rotating electron in the clouds or whatever whatsoever. So that entire model will be out. That means, I hate to say that, certain my colleagues, they teach in quantum mechanics for almost half of their life. They will say, "Are you telling me I'm lying to my student the whole career?" Well, it's a difficult subject.
Well, you're arguing conceptually though, right? From an you're not arguing that the experiments that we've seen around quantum mechanics are flawed. You're saying that we have to look at it through a different lens. It's not this lens of
Different interpretation.
Different interpretation of it. And I don't think there's anything wrong with that. I mean, to me, that's what science is all about. It's about building on previous theories. I mean, science has pretty much always been wrong and then improved over history.
Yes.
So I actually look up to the fact that you are bold enough to say stuff like that. Like, hey, look, I'm saying quantum mechanics is wrong. You know, like generally in academia, people are too afraid to do that because we've got this kept peer review process. And if you go against the grain, then you get shunned by your colleagues. So thank you for being brave enough to say that. There's just a few more last questions on it that I think are pretty quick. What about phase conjugation? So there was this, I think he was a Lieutenant Colonel, Tom Bearden, back in like the 80s, was talking about this idea of phase conjugation, which you take your waves and they perfectly overlap. You can either create amplification, so interference patterns, so either an amplification effect or a cancellation effect.
Right. Destructive.
Mm-hmm. Destructive. Now, imagine that I did a destructive event. So I like to use this rubber band analogy. So let's say I take my waves and I have them cancel each other out perfectly. So they're perfectly in phase or out of phase, 180 degrees out of phase with one another. And I say, okay, I'm going to use let's say 1 unit of amplitude on each. And then I increase it to 2 units each. I would say, okay, standard physics would say both sides are equalizing out, so there's no net force in any direction here. If I increase it to 3 times, there's still no net force in either direction. If I keep pulling on this thing, it's going to rip. It's going to snap, right? So
right, yeah.
The question here is, I'm pulling on both sides. Standard physics says there's no net force.
No net.
Yeah, but why is the rubber band about to break then? You know.
When standard physics say no net force, reference to the center of the mass.
Correct.
You are talking about now. You are talking about that's the deformation part. So internal force, now we come to not talking about it in this called rigid, treat like a rigid body, right? So now we're talking about treat materials as elastic material have deformations, have a local point, different stress, strain. So that's why, even though balanced, however, the internal, if you look at the cross-sectional stress inside the rubber band, it increase.
Well, let me ask this, because I want to put it in context. Now imagine that I'm taking 2 photons, 2 packets, waves of light, and I'm having them cancel each other out. What's happening there? If I have them completely out of phase of one another, and I have destructive interference occurring, what would you say I'm doing physically to reality there? What's occurring? Is there nothing happening?
If 2 photon, we're talking about two like wave. If like a wave, you're talking about, say, a destructive coherence. So that means when they meet, and then you do not see any wave motion, right? Peak and valleys, they are canceled each other, just like a steel, perfect calm weather. Look at the surface of the pond, right? Perfect steel. That's one. It's very rare happen, right? However, if they are constructive, so now you see double the amplitude, right? And you will see this called wave interference pattern. Yeah, constructive.
So how is that possible? Because if that's just 2 waves of light, then I imagine what I just described there is, if it's going to be constructive, I would see a bright amplification of light. If it's going to be destructive, I imagine it would just disappear. But how does that make any sense? Is that true?
Actually, Actually, you just mentioned about that. That's one mystery in the double-slit experiment.
Oh,
We see light cross there, right? Light goes through, we see interference pattern. They said, what happens if we observe the light from the other side? When we observe it, suddenly they said that the pattern disappeared. Remember that episode? Remember that one, right? You know how they observe light? They shed in another light, opposite the direction. You know what happens? They interact, they cancel each other. Right? At least break the original interference pattern. I'm sorry, I probably distracted you, but you reminded me. Yeah, that's another mystery. When they say that we observe, we measured, suddenly wave becomes a particle. What is it? Yeah, wave disappeared, right? Becomes a particle. Yeah.
I guess what I was getting at was trying to figure out if there might be a connection between these electromagnetic waves we call light and potentially the disturbance causing some sort of gravitational effect or some sort of second order effect.
Yes.
And that's kind of what I was getting at, because like I'm pointing out with the rubber bands, like, okay, you have the waves cancel each other out, but it's not really that there's nothing there. There's still this disturbance in the medium.
The material under
stress,
huge
right?
stress. Yeah.
And if that material's under stress, then maybe that stress is gravity or some other, second order effect that might be occurring there. And I just thought that kind of pieced together what we were talking about with respect to magnetism and then this, medium that might be out there. Do you think, have you ever heard of one electron theory? How many electrons do you think?
Oh, I believe maybe 10 years ago or maybe 13 years ago, I watched the one film. Is that a European, is some lead physicist presented the one electron theory? Is that a one video?
Like, if there is this energy out there or whatever, this, that we're talking about here, that this idea of why does there have to be more than just one? Like maybe all of space and time is kind of an illusion, and then it's really just one electron and it's everywhere at the same time. I just wanted to get your opinions on that type of idea in the framework of Uon theory.
I saw the particle based on our daily experience, right? The particle just like one piece of materials, and one electron to explain entire universe electron phenomena. It's a little bit of stretch for me.
Got it.
What do you say?
Yeah, I like the idea, but I guess to me it depends on, for me it would have to be that space and time is an illusion, but I guess I already believe that. So
Okay.
if you take a very hardline approach to general relativity and you say that we're all in our own little reference frame all the time, like all in our own little bubble, then how big or small does that bubble have to be? It could theoretically be infinitely small, so maybe
Right.
everything really is the same and it's all been broken out of some equilibrium. We all come from one tiny little point or something like that. So I kind of like that idea. But the last thought I had on you is another one that's it starts to get into the more esoteric or the fringe aspects of physics, which is, what do you think about the holographic principle? Or what do you think about, the nature of our reality in general and time?
Oh, okay. At least in the area I'm studying, I do not feel there's a true need for that theory. So basically, use Uon theory, magnetism can explain everything, all the mysteries we have. At least I can collect. I also can explain. So I do not feel the needs for that one. So if there's no needs for that one, so I would leave it as a other physicists, let them to imagine, all right? I just leave it out for now.
Well, Dr. Yu, thank you so much for your time. I'll go ahead and give you a moment to just shout out any of the projects or anything that you're working on or any other colleagues that you want. But thank you very much for joining me. Go ahead.
Okay. I hope you have my presentation. If you can turn to the very last page and the second last page, if you can open the PowerPoint file I sent it to you, and I will say, so one is my name, Weiping Yu. I'm the founder of universal particle theory. I call the Uon theory of everything, and try to interpret the entire universe. Use one particle, one fundamental force, and one field, one universe, and simply to explain that one. And also, I want to acknowledge my, if you're looking for additional information, you can look at the website called aneighborschoice.com. anablechoice.com. That's my partner. He's the host of the enablechoice.com website and the podcast and also radio show. And I'm his co-host for the part of that show is called the Science and the You program.
Awesome. Well, thank you, Dr.
Thank you so
Yu.
much.
I know I'll be checking it out. And thank you, everybody, for watching another episode of Hard Truths Podcast. I hope you enjoyed, and I hope you learned some new physics. Till next time. Later, everybody.